Hello, everybody. We are still waiting for a few people to join us, and we will start on the hour. Hello, everyone. Thank you for joining today's webinar. It's the first in a 3-webinar series focusing on supply chain hazard awareness. Today, we look at the first steps in managing the safe transport of sensitive assets. Before we start, however, I wanted to go over a few quick things. So this is a Landsmart webinar. Landsmart falls under the umbrella of the Physical Properties Testers Group, or PPT for short. Some of the other companies under that same umbrella include McMesson, James Hill, and Aluris. If you are interested in learning more about any of our partner brands, you can visit the PPT page and see the content and on-demand webinars they have available. I'll put a link in the chat box for you shortly. That being said, let me introduce some people on today's call. Eric Jonassen is our presenter for today, and my name is Sharon Smorenberg. I'm one of the organizers. Then we have various support staff throughout the United States, Europe, and Asia. So please feel free to ask questions. You can use the question box throughout the webinar to type in any questions you may have, and we will then address these questions at the end of the webinar. The webinar is being recorded, and you will get a copy of the recording to the email that you registered with. If you want to review anything for additional clarity, or if you have a colleague who is interested in attending but wasn't able to make it, please feel free to pass the recording to them. And with that, I will turn it over to Eric.
Okay, thank you, Sharon. Appreciate it. And I am turning on my webcam here just for a minute to introduce myself before I get moving through the presentation content. And hope that, again, that in this brief amount of time that we have together, that you can take away some new information and something of interest here, and try to not make it too serious and on the level of the technical content that's involved here. But I did want to quickly just go through for anybody that's new to these events from the Landsmart side that might not be aware of my company that I work for. I just thought I'd touch base really quick in an introduction about Landsmart Corporation. For those that don't know, so we're headquartered in Monterey, California, where we do our engineering, design, and manufacture of all the products and technology that Landsmart produces, which stretches from test equipment side of things to measurement instruments. And what we really practice and preach is what we call our field to lab methodology, which basically means measure the hazards that occur that are present in things like the supply chain in a given environment, specifically as we're talking about today, the supply chain. Measure those dynamics, understand them clearly in how they occur, and then use those measurements and the understanding to drive what we do in the laboratory with physical testing equipment. So we really practice that methodology, and I'm going to touch on that as we move forward. Just quickly, we also get involved in, obviously, the production of test equipment. And I separate those out into two different categories here: vibration and shock test systems, as well as package testing products. A lot of people, we're talking today about really from the packaging perspective, but what's important to understand is that a large portion of what we do in the products that we supply and sell to our customers are used for product testing, which means before anybody ever designs or considers the type of protective packaging that is used to transport those goods from point A to point B, there's a lot of effort that goes into the design of the actual product itself, the products, the components, all the bits and pieces that are used to configure those final products that then get packaged and shipped. So we get involved in both sides of those types of categories. A little bit more about myself, just in my history of Landsmont. I've been with Landsmont my entire career, which actually now spans, I'm in my 34th year with Landsmont. 11 of those years were spent in the laboratory for me. Landsmont had contract testing labs where we used our own equipment to provide third-party testing services for people that needed those types of dynamic testing services. So although I wouldn't encourage people climbing on their equipment or the test items, just did want to touch on the fact that I spent 11 of my, basically a third of my career managing test labs where we use the equipment to solve problems. And that's really kind of where I developed, I guess what I would say, more of a passion for understanding things, versus just kind of pushing and promoting equipment. It's really understanding the right way to use equipment, the right type of testing to be performed, all in the idea of trying to come up with, solve problems, basically, so, create solutions. I'm eventually here going to start some video, so I'm going to stop sharing my camera so I can focus on the presentation itself. So bear with me here. I've spent a lot of also my time over the last maybe 20 years or so, not only in the test labs performing physical testing, but also within the supply chain. So a lot of the work that I get involved in involves measurement, measurement of these hazards that we're talking about, that I will be talking about today. Climbing inside trucks, underneath trucks, inside rail cars, maybe on aircraft, on watercraft, and in using instrumentation to better understand what is taking place when things are moving through the supply chain, so that we can tell the story of, basically by reviewing that type of information, tell the story of what takes place within the supply chain so we can understand it and use that information once more to drive the type of physical testing that takes place in laboratories. This, just to lighten it up a little bit, because I do so much of this measurement, I touch on the fact over the last few years, including when the pandemic hit, I was kind of stuck. I spend a lot of my time usually traveling, either consulting with people or doing measurement, research work, supporting that even at the university levels. But the pandemic kind of kept me home, right? So I found with a colleague of mine at our headquarters, helped to say, well, what can we do when we're stuck now with this pandemic? What can we do to keep ourselves fresh, exercise, collecting data? So yeah, he came up with this idea called, Measurement Man. And the fact of the matter is I do a lot of this. I did a lot of this over the last 3 years, and I basically look, keep myself, I guess, fresh on the technology and the practice by using my instrumentation here locally and doing whatever I can whenever I'm in different types of vehicles, taking my measurement equipment along, trying to understand what it is so that I can eventually use that information to help better prepare myself when I'm actually doing this kind of package product consulting or measurements within the supply chain. So I get involved in quite a bit of that activity. But now I'm going to jump into this, kind of what the fundamental of this presentation, which is really this, as we focus on the supply chain, but not only on the supply chain, but how that relates to packaging and products. And so what we use is this fundamental simple formula to try to describe it, kind of in a high level nutshell that basically says the product plus the package has to be equal to or greater than the environment. And what that basically means is the durability of the product plus any contribution from protective packaging has to protect that system, the product package system, from all the hazards that are present within this environment. And when we say the environment, that's kind of synonymous with the supply chain. Another way of looking at that same relationship, distribution environment has all this bad stuff that can occur. You know, it's got all the different modes of transportation, aircraft, rail cars, trucks, over the ocean, different types of ferries and ships. And within that, there is risk, right? There is risk from the shock and vibration perspective. We think of ourselves as really, at Landsmont, myself as a shock and vibration expert, or we have shock and vibration expertise. We understand these dynamics. And there are a lot of those, and they're unique. There are a lot of them that people are going to be faced with when they're moving things through the supply chain. Well, depending on what the design of your product, the configuration of your product, what type of product it is, if it's very robust, you might not need packaging. I mean, sorry, not sure where that popped up. See if I can get rid of it. Can you still hear me? There, okay, sorry. So we think in terms of protective packaging from these types of hazards, shock and vibration. So if you think of products, maybe even like mobile phones or things like inkjet printer cartridges, those are very robust items, right? So they don't require packaging that's going to protect them from things like shock and vibration necessarily. Yes, you still may need packaging, but it's more for theft protection, from cleanliness, to keep things away from like dust and dirt. But it's not really required in some instances from a shock and vibration perspective. The reality is, though, I'd say most products aren't that durable. You know, across this wide, diverse spectrum, you have products with some type of inherent fragility that is going to require them to be protected during transport through the supply chain with protective packaging. So that's what this shows. We have a product, it doesn't have enough fragility, we make up the difference with protective packaging. That's a good situation, or it's an okay situation. But in this situation, if we don't use enough protective packaging, obviously, that's, call it under package, but what that really means is you're going to have experience damage. You can experience product damage within supply chain. Alternatively, if you use too much packaging, you might be okay from a damage perspective, but what you're doing is you're leaving money on the table because you overpackage, you maybe use too many materials that weren't really required to protect your product within that supply chain. And that's, you know, probably the result of the fact that in that scenario, the designers don't really clearly understand the durability of the product or the protective qualities of the packaging. So this is kind of the last scenario that we like to show is this is an ideal situation where the product and the package still equal or account for the hazards in the transport environment. But what we've done is, if you notice that or not, but what we've done, instead of using or addressing that completely with protective packaging, what we've done is we've boosted the durability of the product itself. And so the idea there is if you make or use a greater effort or invest a greater effort into the design of products, and you're able to make them more durable, what you do is you obviously lessen the need for expendable protective packaging, and you increase really the inherent value of that product, and that added value stays with the consumer or whoever bought that product. So it's really an ideal situation, and there is actually a methodology that you can use to try to achieve that outcome. And so I'm going to touch a little bit moving forward on each of those categories: product, package, and then end with a more involved discussion on the supply chain itself. But because I'm trying to touch on this relationship, product plus package has to be equal to or greater than the environment, I just want to touch on product durability. So from the product side, Some people are aware of this, some people may not be aware of this, but there are industry standards that exist for how you test products, all within the idea of establishing an understanding of their durability or their fragility, such that this all occurs before that any of the package, the selection of the packaging materials or the packaging design takes place. So for Landsmont, shock test system, like I'm showing on the right-hand side, there is a procedure. This is just one example of an industry procedure, ASTM D3332, which is a test method for mechanical shock fragility of products. And basically, this is what it looks like. Obviously, a very simple video there with a light bulb, but the idea is with these types of machines and those types of procedures, we can program different types of impacts with that machine so that we can generate actual data, right? Meaningful data or analytics that speak to, or give us the information that says this is how high I can drop that product without any packaging at all. So it gives you that type of information. This is how much energy it's going to require to break this product. Not only how high I can drop the product, but then from that drop height, how many G's of acceleration can it handle before some type of failure occurs. And again, why would you do this? The reason you do this is because you use this information in part to help specify the required protective packaging, right? I mean, you have to understand some type of characteristic about your products before you ever start down the path of designing and specifying packaging material. So there is methodologies, standard methodologies for how you go about defining shock product durability from a shock perspective. And what I want to point out by these images, this is a picture on the right-hand side of one of our higher performance shock test systems. And then the image in the middle, or on the left, that was just sent to me this week from a colleague at our headquarters in California. So again, most people think of Landsmont as maybe a package, provider of package testing products in the packaging sense. But we, just as an example, we have a large portion of our business that goes towards product testing. So these are, this is only one side of our production floor, but at any given time, these types of machines are lined up in our facility because they're going to a number of different companies, a diverse subset of companies across industries that are performing that type of product testing. Vibration fragility. So I just touched on shock fragility, but the other side of things is determining product durability or fragility in terms of vibration. And so both of those, shock and vibration are kind of the two dynamic hazards that people are concerned about when things are moving through the supply chain. And your packaged products are exposed to those hazards in a number of different ways. But that's still really the bulk of those two. They can be summed up into those two categories. And so vibration is different than shock. Shock is big as far as is the amplitude of it. It's high intensity, goes bang, and it's very short durations of time. It's what we would call transient in nature. It may happen, it may not. Where vibration is something that is lower intensity, but it happens more frequently. Anytime something is moving, it's experiencing vibration, right? Anytime it's moving down a conveyor line, maybe being handled by a forklift, then it goes onto a truck, or it goes onto a rail car, or even goes in an aircraft. And that, whenever it's moving, it's experiencing vibration. There's no way to avoid it. And so what happens when things are vibrated is things get excited. Components, the products and the components get excited. And so what I'm showing here is a video of a vibration sinusoidal sweep, which is something that in the background here, you can see a table. There is a little model I have set up with a piece of instrumentation on it, and basically a beam that's hanging off the table. And so what we do is we set up that table to sweep through a frequency range. where the table is shaking at different frequencies. And what we do is we determine when those products or when those components get excited. So I'm going to go back real quick and show what that complete video. As it's sweeping, you see the trace gets higher and higher and higher until a peak occurs, and what that identifies is what we call the resonant frequency, or the natural frequency of whatever it is that we're measuring. This is another example. So that was an example of 3 different spring mass systems that are mounted to a table. You can see there's 3 springs there with different sized masses attached to each of those springs. And you noticed, if you could hear, the table was changing its frequency, sweeping higher and higher, going from a lower frequency to a higher frequency. And what we're able to do or demonstrate there is the fact that depending on the mass that's on top of those springs, they each had what we would call a different or unique natural frequency, which is identified in that trace just to the right of the image itself. So the big heavy mass had a natural frequency of 28 hertz. This mass had a natural frequency of 35 hertz. This mass had a natural frequency of 46 hertz. How do I use that? Or what does that mean to me? Again, these are mocked up examples to help demonstrate things. But the reality is, in the supply chain, if you're moving products through that supply chain, depending on what type of product it is, think of a medical device, think of a display, think of a laptop computer, think of any type of mobile electronics. The bits and pieces of the components that make up that product, you can think of them as having these type of what we call spring mass systems inside those products. And what happens is those different components get excited at different frequencies while they're moving through the supply chain. So what does that look like in an actual product? Here's an actual product. This is a desktop computer where we take the cover off of it, and you can see the circuit boards inside those computers. So that's a circuit board in the computer, and it's what the machine is dwelling at a specific frequency, sitting at that very specific frequency where that circuit board likes to get excited. Now, if I play this further, this is now in slow motion. Oh, sorry. In slow motion, you can see that circuit board gets very excited and actually starts to move quite a bit, right? There's a lot of displacement there. That's the smaller circuit board right above it at a different frequency. And you can see it likes to shake at that frequency. So it gives you an idea, hopefully, by seeing these videos, that vibration can cause problems, right? And what it can be is they can cause fatiguing problems. And so it's not necessarily like this catastrophic type of failures that you might see if you drop a package, but they're more of things that you can think of over time, that wear and tear, that can cause abrasion and scuffing, or flexing so much that eventually that fatigue causes cracks in different materials. So it's a concern. It's very much concerned, both shock and vibration on products that are moving through a supply chain. This is another real example of 2 bottles, two what we call growler bottles of that I have full of liquid and actually was transporting in my car. And you look at this resonance. And it might be hard to hear and to see, but those 2 bottles are resonating at certain frequency, at 14.5 hertz. And even though that might not look very exciting, but over time, that impact, multiple impacts, or rubbing and abrasion can cause real issues and can cause things like label scuffing to occur. And that might not sound like a big deal, but it is, especially, obviously cosmetically it's a big deal, but it also can be a really big deal in areas like regulatory issues. So medical, pharmaceutical products. If you ever have issues where labels, any of the prescription information or tracking information could get scuffed off of labels, that can be a very big issue. And so, these types of responses to those types of input energies are critical to understand. And why is that? Because we can use packaging materials, right? Now we can use or engineer packaging materials to help avoid those types of responses, or to mitigate those types of responses. Basically, they act as packaging materials can act as filters to assure that type of energy never makes it through the package and into the products, so that you never allow those bottles to bang against each other, or that you never allow the energy to excite the circuit boards inside the computer or a television. And so there are different criteria that are, when you select packaging materials, which these discussions can be courses all on their own, which we will plan to host at some point, get into the details of how you go about specifying packaging materials. But at the very least, I wanted to make the point here that there are things, engineering tools that are associated with packaging materials from our shock and vibration world. So there are things called shock cushion curves, and there are other types of data sets that are called vibration cushion curves, which are used and can be used. When you generate that information on dynamic testing equipment, those types of cushion curves, but then you can use that type of information to help specify, once again, the materials, the amount of materials, the type of material, and where to use that material in your package, so that it filters that energy, that shock and or vibration energy, from making it to the sensitive product and or components within that product. And it's again, an engineering process. So you get, but in order to select the right materials, again, you need to understand your product characteristics, right? The product fragility. They're not either of these done in a silo. You really need to do it in a kind of an engineering process that first says, how tough is my product, or how fragile is my product? And once I understand that, then I'm better equipped to go, set my design criteria for my protective packaging. So now moving, just touched on those briefly, but now to the supply chain side of things, okay? Understanding supply chain, which is really what we're talking about with this webinar, is really focusing more on awareness of what takes place in the supply chain. So some unique things associated with the supply chain, right? And you can see it obviously within any of these videos. And what's unique to this? What's unique? Yeah, there are different modes we're looking at here: rail cars, trucks, maybe forklifts, the types of dynamics that we're showing here. And what's should be obvious here is that things are moving, right? So there's movement, there's motion. And so whenever there is motion or movement, there is risk. There's risk associated with the supply chain, right? So I have a packaged product, and if I'm going to move it from point A to point B, that means risk throughout that change from location of point of manufacture, maybe to the point of end use or the consumer. And changes occur while it's moving. Okay, that's the key thing from our side. There are changes, and there are different types of changes that occur when things are moving in the supply chain. There are dynamic changes, meaning motion, and there are climatic changes, which are critical to understanding. Climatic, just some of the key ones: temperature. There's changes in temperature. There's changes in humidity, or relative humidity. And there are changes in atmospheric pressure, thinking altitude. Things are flying in aircraft, or they're going over mountain passes, whether it's over the road or over the rail, there are changes, and those changes can affect the performance of the packaging or the viability of the packaging because of things like humidity, just general number. High humidity conditions can actually weaken the protective strength of things like corrugated or cardboard materials by as much as 50%, just by having to function in very high humid conditions. Atmospheric pressure. If you think of if you've flown, you have a hand of maybe either a cup of yogurt or a cup of juice or a bag of potato chips or pretzels. You notice that the pressure, the change in that pressure affects that package, right? And even with, let's say, yogurt or a soup or something, if you open that lid, it might come squirting out at you. And that's because of that pressure differential. And that can be a real big deal when you're talking about things like food products or medical products, the sterility of that. Those changes are critical to understand and then eventually validate whether things can withstand those changes through testing. From the dynamic side, if something's going to move from point A to point B, obviously it changes position or location. And that infers that there's a change of speed that occurs, right? Things move either fast or slowly through the supply chain, but there are changes of speed. And then also associated with that are changes of acceleration. As things speed up and they slow down, that is basically the definition of acceleration. And so all of those things, considering all of those, we think of those in terms of laboratory testing as, well, how do you, what are you saying? What does that really mean? Well, it means that that's by understanding those changes, we can define things in terms of shock, the hazards in terms of shock, impact, vibration, compression, shifting. So think of a pallet load of boxes or bottles. If a vehicle turns or brakes or accelerates too quickly, the loads can shift in one direction or the other. And in worst cases, they might tip over. So we need to clearly kind of understand all of those hazards within the supply chain so we can kind of put our arms around them in terms of the categories like over on the left: shock, impact, vibration, compression. Those are all types of hazards that are accounted for when people perform the industry standard laboratory testing of packaged products. So we spend a lot of time, again, not only understanding it from what does it look like outside the vehicle, right? What does it look like outside the vehicle, but also what does it really, more importantly, look like inside the vehicle? This is video from inside of an intermodal container that we're measuring with sensors, but also with infrared cameras, to give you an idea of how things respond. This is a container being handled in an intermodal rail yard. And what's interesting there is, again, we're using measurement tools to understand the shock and the vibration kind of dynamic side of that, but by also observing with our eyes, with cameras, and also hearing with sound, and maybe even including GPS with this information, we can pinpoint those types of dynamics right to something like an intermodal rail yard, where those containers are being picked up off of a truck and being transferred onto a rail car. And, again, does everybody understand that or appreciate those types of dynamic events or forces can actually occur just in handling of intermodal containers? I don't know if you noticed, but even those pallet loads, you see now the two loads left and right, side to side. Before all that handling occurred, there was a gap between that row of palletized products. And after the end of just that short little bit of handling, that gap closed. And now those loads are touching one another, which isn't necessarily a good thing. Because once things touch each other, remember, once again, that the in terms of then vibration, as it moves forward, when things are touching each other and there's the interaction of surfaces right next to each other, that can cause wear and tear and breaking of the protective packaging surfaces just by all of these things kind of cumulatively happening together. Here's something else. This is real. This was taken at an airport loading facility in China by a customer that we were working with years ago, where you think, do packages really get handled roughly? You know, do people really throw them around? This is video, relatively recent video. You can see that the brands or the names on some of these packages, a fair number of Amazon boxes, but this is a transport in India and how things are handled. And this is something that's called the clamp truck. And if you notice right there, what happens when it's basically compression from the side, right, versus compression from the top, which maybe most of us think of as when we think of compression loads, it's from stacking or from packages on top of each other, moving through the supply chain or either sitting in a warehouse and experiencing those compressive forces. But what we're finding, again, more and more from awareness from supply chains is that this type of handling, this clamp compression, is a big deal. It's a big issue because, quite frankly, a lot of people that design packaged product systems probably are not accounting for the fact that that the force that it's going to experience those forces or those clamping forces in that axis, in that lateral direction versus top down, where from a packaging perspective, you might have your column strength and things associated with individual packaged products. All the strength is vertically, right? Most of it is, but maybe not laterally. So it's very real, and it's important to understand and be aware of that. So why do we do this? Why do we do these kind of measurement and observation efforts? And it's obviously to try to understand what happens. What is it? What happens out there? What are those hazards in the supply chain? How much of it happens? Not just like did one big bad thing happen, but how many of those things happen? How many times does it potentially get hit or drop during shipment? A normal shipment, an international shipment. How many times? How often does it happen? And obviously, how severely does it happen? So things might get bumped quite often, right, in the supply chain as it moves from point A to point B. But are they small things, or are most of them small, statistically speaking? What's the 90th percentile, the 95th, the 99th? What's the maximum exposure that I'm expecting to see from a shock, vibration, or maybe even a compression perspective? And what do I do with that information? Why do I want to know that? And obviously the most general one is to create an overall awareness, right, and appreciation of the hazards that do take place in the supply chain, and specifically in your supply chain. Because a lot of times, depending on who you are, you have a unique supply chain. If it's a cold chain, if you're shipping pharmaceutical products or biological products, you ship in a cold chain. Is that unique and different than somebody that ships in full truckload or LTL environment? It likely is. Or you ship from Asia to South America as compared to maybe from Europe to North America, or you go from Middle East to Asia or back and forth. Is there something unique about that supply chain that's different than the supply chains that you're used to operating in? And so why else would people do all this measurement kind of effort? Trying to understand as they create new package performance test standards. And that could be individual companies that are creating their own package test standards, or it's the industry standards, which I'll talk to you about here in a minute. But you can think of an ASTM or an ISTA or ISO. They create new test standards based upon that information. Or some people compare their current testing methodologies to information that they generate from their supply chain, basically as a sanity check that says, listen, today I use the ISTA 3A test procedure to validate or verify the performance of my parcel package, shipping my packaged through the parcel system. But I want to know if that's still valid. You know, is something changing? Do I have reason to be concerned that something within my supply chain is more hazardous or even less hazardous? So they'll do studies where they compare the real world supply chain scenario to their controlled laboratory testing standard. And if necessary, they adjust it, right? And that's not, I mean, again, all these scenarios are things that I work with quite frequently in my day-to-day operations. I help people perform these studies. I help them make sense of the data and make decisions based on that data that says, do we need to change anything? Do we need to up it, you know, or increase the level of severity that we're testing at, or could we potentially lower it? And if you think in terms of people like on the medical regulated industry, what they really need for any of their decisions is in the direction they're headed with their testing. If they're raising or lowering or changing the type of testing they're performing, they need to establish data-based, dependable positions, which means basically documents. Show me the data. Show me the data that one way or the other that I can stand behind for my actions moving forward, whatever that may be. So that's why a lot of people also measure. Okay, so now jumping ahead, you know, as we develop these understandings of the supply chain, what do we do with that information? We talked about some people, you know, will even go out and create their own test standards, but here are, you know, industry, the big ones in our industry organizations that develop and maintain laboratory test standards for simulating the supply chain or the distribution environment. ASTM, ISTA, which stands for International Safe Transit Association, ISO, obviously, and another one is called UMOS, which is based in Europe for cargo securement, all of which issue and maintain their own test procedures. ASTM D4169, I started back in my career back in 1989, let's just say the 1980s, but it's one of the largest ones, historically speaking. It's got a lot of precedence for this type of testing, you know, performing supply chain shipping simulation. And so we really, you know, in our world can trace the origins of this type of testing in a more complex manner to a study that was performed in 1979, basically a supply chain study, you know, an awareness study. This is what I'm talking about here. And this was a study that was performed by what's called the FPL, or Forest Products Laboratory, in 1979. Okay, this is what the document looks like. Talks about handling, vibration from trucks, rail cars, aircraft, ships, shock from the same types of modes, rail car dynamics from things like coupling impacts, where the rail cars are being put together, you know, building a long train. And you know, there's data. So this is kind of the first origins of, if you're going to perform this testing, here is some data that was generated as a part of this research back in the 70s, and then eventually resulted in this document that was issued in 1979. And that's where we really kind of trace the origins of the original ASTM D4169 test procedure, which is very well known in the people that use our type of technologies, testing technologies. And as present, there's a lot of small print here, but what I wanted to point out is part of the current issue, the 2022 issue of ASTM D4169, there are now 18 different distribution cycles as part of that document. So you can think of those as really 18 different types of test scenarios that are included in that document. Instead of just being one, you can see, maybe you see some of the different names there, but like motor freight, full truckload, motor freight, less than truckload, rail only, rail, trailer on flat car, container on flat car. There is air profiles, distribution cycles. So there are a number of different distribution cycles, 18 of them current, you know, and that is all based upon data that has been collected and presented over the years. Obviously, it started in 1979, but it didn't stop in 1979. Over the years, people, you know, there's people in these organizations meet continuously to look at the procedures and see if anything needs to be added or changed. And so in this example, ASTM up to 18 different distribution cycles. ISTA is another one that's very active in the development and maintenance of industry test procedures. And just, to be transparent, I participate actively in both of those organizations and am part of the ISTA's Global Board of Directors. So I'm quite aware of the history and the development efforts in both organizations. And you can see within ISTA, there's even more than 18 test procedures. They exceed 20, maybe close to 25 individual test procedures right now that they've developed for different environments, including, well, you can basically see the different types: parcel delivery, LTL, manufacturing distribution center, club stores, European consumer goods. There's obviously the Amazon test that most people are probably familiar with if you're familiar with ISTA testing at all. And the ISTA 3A, which is for parcel delivery, is another very widely used one, even globally speaking. And the other thing about ISTA is that not only do they create and maintain these test procedures, but they're unique in the fact that they can fund and do fund research. And that's unique, I think, in terms of a industry standards body organization, is that they don't just kind of wait for anybody to bring new data to them and kind of discuss as a group, as a consensus body group, if and how to move forward. But they also fund research, which is through membership. But they fund research to go out and look at continuously what's taking place in the world. So this is just a screen capture I took from their website that talks about the Distribution Environment Data Collection Program. Fine print down there, it basically identifies what's currently, the 5 primary targeted geographic regions where they want to go out, or we as an organization want to go out and develop a better understanding or awareness of the supply chain hazards in those regions. And I point this out, I say there are 5 of them, and what I can tell you is that there's been an India study that's been completed in the last, I think it was maybe 2 years ago that it was completed, a large study. There is an EU study that was just completed that I helped actually participate in, that took about 2 years to complete, or 1.5 years. And China study in China is in progress as we speak. So this is, an active effort and funded effort through ISTA to not just sit back and kind of take advantage of just the current test procedures, but it's actually active and proactive in going out and looking at different environments to see if things need to change. And so, this is just even as of last month, some different studies that would have last 6 months, some different studies that we have helped support from a measurement and research perspective, where the results have been presented in summary at a couple of the different ISTA events, one in Berlin and one here in the US in San Diego, very large scale measurement projects. The single parcel shipping environment project on the bottom right, that involved over 1,000 instrumented shipments throughout the North American supply chain using UPS, FedEx, and the USPS, which means the United States Postal Service. Over 1,000 instrumented measurements of different size and weight categories, which is just a huge, huge undertaking and effort, all with the idea of using that summary data to drive potentially changes to ISTA test procedures, for instance, like within 3A, if it's warranted and justified, but they will be data-based decisions based on really comprehensive data. And lastly, what I'd like to mention here is that ISTA also offers what are called data analysis and collection guidelines. And this is, these are available on their website. I think you can purchase them, but also if you're, ISTA members, you have access to these documents that basically tells you how to go, excuse me, how to go about doing these studies, right? If you're going to go out and collect data, shock and vibration, temperature, humidity data, basically data from the supply chain, here's how you should do it. Here's how you should collect that data. Here's how you can analyze and report on that data. Obviously, you can do whatever you want as an individual person, or company that goes and collects this data. But ISTA's perspective is listen, we are a standards body organization that develops these standards. So if people are going to present data to our organization, and with the idea that we're going to potentially create some new test protocol based upon that data, we want that data to be collected in a way that we believe is the right way, right? So that it will give us clean data or actionable data versus questionable data. So basically, they've established these guidelines that says, hey, if people are going to go out and do these studies, whether we fund them or people go out and do their own thing and then present us with that data, we'll look at it, but here's how we want it collected at a minimum, which is really, I think, a really positive step, because it basically tells people how to go about doing it, but it also establishes a level of quality, expected quality, to the fidelity of the data that people are using. And again, why are we doing all this? It's back to this field the lab methodology. We do it, we go out and observe and generate awareness through all this type of measurement, because we try to connect the dots, right? We try to connect the dots from what is happening in the real world to how we can then drive what we do in the controlled laboratory, repeatable environment to those packaged products, all in an effort to predict how well they're going to perform within the supply chain. So that's really, it's that awareness that allows us to pick and choose the right types of testing and the right intensities that we perform in the laboratory when we do this type of testing. So that's I'm a little bit longer than I wanted to be. I apologize for that, but coming back full circle to what I said I was going to cover today was this relationship of product durability plus protective packaging has to be equal to or greater than the hazards in the transport or distribution environment. And so I tried to touch a little bit on the product durability, protective packaging, and maybe expand a little bit more on the supply chain and supply chain hazards and distribution hazard awareness. Thank you for your time. If you're still connected. I did want to mention that moving forward, we have 2 more webinars scheduled that we will be delivering, that I will be delivering. Next one being Wednesday, November 2nd, where we're going to talk about field data loggers in this example, or in this specific seminar, the difference between monitoring and measurement applications, how to use the data loggers to go out and do these types of measurement projects. And then Tuesday, November 22nd, we're going to get into more of the technical detail on shock and vibration specifically. What are they? How do you define shock and vibration? And really, why do I care? What does it do? And why should I be concerned with it? So I wanted to mention that. We'll be promoting those here moving forward. Sharon, who I'm going to transfer over to here in a second, also I think is including links to those registration pages if anybody's interested in attending those next subsequent sessions. So with that, I'll stop and pass it to you, Sharon, and see if anybody might have any questions. Thank you for your time.
Thanks, Eric. So if anybody have a question, they can enter it into the question box now. Eric, I'm hearing a bit of an echo. I'm not sure if your mic is on, but so just we have had a question come through already, and the question is, how should I interpret the vibration curves? Eric, I don't know if you can quickly answer that for us.
Not quickly, but I mean, I could talk about it all day long. So, and I would be happy to do that. And it kind of depends on which curves, again, there's probably a number of questions that then I would need to ask to properly address that question. But I absolutely can help with that. I just don't know. It would probably require me to ask more questions before I could answer it. But it's pretty cool. And quite frankly, I'm not trying to promote or push anybody into one of the next webinars, but I would specifically get into that detail of that third one where I talk about what is shock and vibration and why you are concerned. I would definitely be addressing vibration in terms of PSD curves or PSD plots, as well as the plots that I showed on the screen earlier in my vibration examples, which is not PSD. That's literally what we would call transmissibility data.
Thanks so much. And also, we are showing Eric's email address on the screen, which is just eric_jonassen@landsmont.com, if you want to reach out to him specifically with a more urgent question. So thanks again for joining us today. We look forward to hosting you on the 2nd of November for the second webinar in the series that Eric mentioned is going to handle information on field data loggers, monitoring versus measurement. Thank you very much for joining us and have a good day. We will now end the webinar.
Thank you.